Hey, so for this video we're gonna go over an example on how to find probability of independent events. Let's remember that independent events is those events where the occurring of one of them does not affect the occurring of the other one, or they don't affect each other at all. One example can be when we flip a coin, right? The result that you get in one time that you flip the coin does not affect the result you're gonna get if you flip it a second time or you flip it a third time, right? So that's an example of an independent event. Another one can be when you roll a die as well. Whatever outcome you get on the first time that you roll a die does not affect the outcome you get when you roll the die a second time. Or if you roll two dice, right? They don't. Whatever outcome you get for each one doesn't really affect the other one. So those are examples of independent events. I'm going to go ahead and read this problem, and I'm going to point out a keyword that it's always going to let us know if we're working with independent or dependent events. So in this problem, it says that an urn contains 3 red balls, 2 blue balls, and 5 white balls. A ball is selected and its color noted. Then it is replaced. A second ball is selected. Find the probability of each of these the following examples and following options that I'm going to give you. So for the first one, it says selecting 2 blue balls, right? So what I wanted to point out in that keyword that it's always going to tell us if we're working with a dependent or independent event is the word replaced. This right here, it's already telling us that the first time that we select the ball does not affect the second time that we select one because we are replacing it. So we are putting it back. We still have the same amount of balls, same colors inside of the urn. So the first outcome is not affecting the second one, right? You're still gonna have the same amount that you had on the first one. So that word replacement, replaced, it's telling you this is going to be a set of independent events, right? Now for this one, it says selecting 2 blue balls, right? So we noticed, and it was given to us from on the slides, that we have the formula for the independent events. And for that, I'm going to go ahead and write it down. So the formula for independent events is that P of A and B equals P of A times P of B. So we're pretty much multiplying the probability of both events, right? Now I also want to point out how for this independent event we are working with a multiplication, and how when they're asking us for probability they use the word and. Okay, I wanted to point this out because you notice on the other videos, the previous videos for the other slides, we're talking about the addition rules, and for addition rules we use the word or. So I'm gonna go ahead and make a note, and if you can go ahead and write that somewhere in your notebook or on the paper on your homework. When we are working with the word or, so if we're saying find the probability of A or B, or let's say the probability of selecting a red ball or a blue ball, right? If we're working with the word or, that means we're going to be using the addition rules. Okay? But if we're working with the word and, then we are working with the multiplication rules. Okay? I just want to point that out just so you know what formula to use when you encounter the different type of problems on the homework or on the exam, right? So if we have the probability of one event or another event, then we use the addition rules. If we have the working with the probability of an event and another event, then we use the multiplication rules, because we for sure are going to be working with both probabilities, so we need to multiply. Whereas in OR, we're trying to find the probability of one or the other thing, so that's an addition rule. Okay, just wanted to point that out. Now I'm going to go back to the problem. So again, we want to select 2 blue balls from the urn, and this one says selecting 2 blue balls. So that means that we're going to find the probability of a blue. Oops. So selecting on the first selection, selecting a blue, and on the second selection also choosing a blue ball. So that means that we want to find the probability of a blue times probability of a blue. So again, this is on the first try, right? And this is on the second try. So now let's see, what is the probability of selecting a blue? So basically it's having the number of blue balls in the urn over the total number of balls inside of the urn, and then same thing here, number of blue over number in total. So this number in total is basically our n of s. Let's remember n of s is the total number of possibilities and outcomes that are possible and existing in this situation, right? So here, how many blue balls are in the urn? There are 2, so we're gonna have 2 over, and then how many balls are in total? We have 3 red plus 2 blue, that's 5, plus 5 white, that's 10. So we have 10, there are 10 colored balls. So 10 colored balls in total. So we have 10, so it'll be 2 over 10, and then times, again, 2 over 10. So notice we still have 10 in total by the second time that we select the ball, because we're replacing it, right? We're putting back the first, let's say the first blue ball that we selected. Now we go ahead and multiply. Let's remember that when we are multiplying fractions, we do it across. So this will become 2 times 2 is 4, and 10 times 10 is 100. This can be reduced by 4, so we can divide by 4 and by 4, and this becomes 1 over 25. So the probability of selecting 2 blue balls, so 1 blue ball in the first selection, putting it back, and then another blue ball on the second selection, is 1 over 25. So that is the first example. Okay, now let's go ahead and try another one, a little bit different. Let me make this, well, I'm gonna leave it like that. I was trying to make it thinner, but okay. So let me get rid of this, and let's try a second one. So this was A, now let's try B. I'm gonna leave the formula for the multiplication rule, and I'm actually going to enclose it so we don't mess with it. So for part B, we want to find the probability of selecting a blue and white. So I'm already like writing it into formula form, so no. Let me go back to selecting a blue ball and a white ball. So again, for this one, the key word for us to know that we are working with a multiplication rule is the fact that it says the word n. So that means we're using multiplication. And And again, because it says replaced, right, in this situation, then we're working with independent events. So now that we have this, let's go ahead and work it out. So we have the probability of selecting blue and white. Right? So that means that we're going to do the probability of selecting a blue times the probability of selecting a white. So the first one represents the first selection, and then the second one represents the second selection. So for the first selection, again, we want to find, keep moving this. There it is. Okay, so we want to find the probability of selecting a blue. We know there's 2 blue balls inside of the urn. So this will be 2 out of 10. Remember, we said there were 10 balls in total inside of the urn, times, and then the probability of selecting a white, right? So how many white balls do we have? There's 5. So we're going to have 5 over 10. So again, 10 is total number of balls, and then 5 is white balls inside of the urn. Okay. And now we go ahead and multiply across. So 2 times 5 and 10 times 10. So 2 times 5 is 10, and 10 times 10 is 100. And this becomes 1 over 10. So the probability of selecting a blue ball and then a white ball, it's 1 out of 10. Okay. So this was a little bit different because we're not working with the same color, right? So our values changed, our probabilities changed. Now let's go ahead and try a third example. There it is. Okay. So for part C, we want to find the probability of selecting one red ball and one blue ball. So first one red, and then on the second try a blue one, right? So we want to find probability of red and blue. And again, I'm going to go back to that keyword that it's telling us is our independent events will its end, right? So here I use the symbol instead of writing the word end, but that right there is telling us that we're going to do the multiplication. So that means we want to do probability of selecting a red on the first try times probability of selecting a blue on the second try. So the probability of selecting a red, again, is the number of red balls inside of the urn over the total. We have 3 out of 10 times probability of a blue will be 2 out of 10. Now notice how now I'm using a dot for the multiplication. I was using the little X mark for the other for the previous one for part B. I don't care, you can use either the dot for multiplication or the little X symbol for multiplying. I don't really mind as long as you know that this is a multiplication rule. Now we go ahead and multiply across, so 3 times 2, and that is 6, and then 10 times 10, which is 100. We can reduce by 2, and this is going to give us 3 out of 50. So the probability of selecting one red ball and then selecting a blue ball for this independent event it's 3 out of 50. And so these are just a couple of different examples on how to find the probabilities for independent events. Let's remember, we always want to find keywords on the situation, and one of the most common ones used is the word replacement or replaced. If we're talking about selecting a ball, a marble, a candy, a card out of like a bag or an urn, a box, they always use the word replacement or replace, and that's how we know it's independent. Something else or another type of problems is when we're flipping a coin, or when we're flipping a coin, or when we are rolling a dice. Those are also examples of independent events. Another one can be when we are answering a questions or a multiple choice questions on a test. The answer that you provide in one, if the question is not related to the other ones, right? The answers that you provide in each question on the test do not affect each other. So that is also another example of independent events. So this is just a different things and different problems that you might find and encounter in the homework, where you will have to use a multiplication rule, saying that they're independent events. And also pay attention on what is the probability of what are they asking you. Is it a probability of one event and another event, or the probability of one event or another event? So that changes the rules that we have to use, whereas it's an addition, right, or a multiplication.